right, sounds good. So I'm KK. Kshitij Kumar is my full name. Nobody can pronounce it, so I go by KK. I'm the Vice President for Data Infrastructure at Zalando. What does that mean? I basically own all the central functions for data. What that means is everything from the business intelligence to the data warehouse, data lake, machine learning, artificial intelligence, all the visualizations, basically everything that you do when you go to Zalando.com. If there's data in there, we are doing something underneath it to make that happen. All right, so starting. Zalando is just a 10-year-old company. It is, of course, all about fashion. We started out in 2008 as just a very simple online shop. In fact, when I came here, I moved here from Silicon Valley in 2018, January, last year. I had lived in Silicon Valley for 20-some years, built several companies, done a lot of stuff. I had never heard of Zalando. And so I was on a sabbatical. I was thinking, what do I do next? And this gentleman called me and started talking to me about Zalando, and he was a senior vice president there. And I really liked what they were doing, the vision that they had. And I said, all right, let's go check this out. When I went to the website, of course, I didn't see that 2008 picture. I saw the 2018 picture, actually 2017 at that time, which was very impressive. Living in Silicon Valley for 20 years, I haven't seen that many companies that went from 0 to 6 billion euros in revenue in 9 years. And it's still growing. It's growing at like 20% a year. It's profitable. Amazon wasn't profitable for most of its life, right? So it's an interesting place to be. Just a quick backgrounder on a few things. So for those of you who don't know Zalando, we sell about 300,000 articles from about 2,000 international brands. We have our own brands as well. We have localization underneath. What does that mean? If you're in Munich and you are searching for something on the website, what you will see will be different from what you would see if you were in Berlin and doing the same thing, or London, or Dublin, or wherever in Europe. We have 17 countries that we cover. We have stylists, etc. We have curated shopping, which is basically I can go to the website and I can say, hey, I'd like to let you tell me what I should be buying. And I give you some pictures, or I tell you what I like. They show me some pictures. And based on that, they will tell me what might be good for me. They send me a package once a month. And the interesting thing is, right now, most of it is not AI. Most of it is actually humans looking at it and going, all right, maybe we should suggest something to you. And but over a period of time, I'm expecting this would be AI. This would be a use case of AI that you would not see. It would still look like it's a human looking at you, deciding what might be good for you. And then it's up to you. You keep it if you want. You don't keep it if you don't want. Of course, the funny thing about me was they sent me, I think, 8 articles, and 5 of them were things that I basically already had. And so they were so good at it that I was like, this is no use. Give me something different. So interesting things that you run into. Now, of course, Zalando is an enabler. What does that mean? I told you there are about 2,000 brands. We have many, many customers. We connect customers with the brands. And of course, as an enabler, who also is selling your own things, everything that we do is based on data. Data based on what people did on our website, what people did with the things that they bought from us, what people did with things that they didn't actually buy, put it on the cart, and then went away. Or maybe somebody put it on the cart, came back again a week later and bought it. All of this information, that's what actually drives Zalando. It's data. So what that really means is we are a tech company. We are a 15,000-person company with a lot of people working in the warehouses, but we have over 2,000 tech people. We are, luckily, a very young company, so we were able to do a lot of things on the cloud. Right now, I have 3 clouds, Amazon, Google, and Oracle, that we use today. We have 8 international tech locations. We do data across all of these. And we've got our headquarters in Berlin. If anybody's out in Berlin, wants to have a beer with me, give me a call. So let's talk big data. Like I said before, data is at the heart of everything that we do at Zalando. Now, think about it. Before you actually go to the website and buy something, That item, that article, has to be manufactured by somebody. It has to be shipped to us. We have to make a decision to buy that. Once it has been shipped to us, all that warehouse work that has happened, it has to be put up on the website. And it has to show up when you search for that thing. All of these things, every step behind it is based on data. Starts really with the operational side. That's what I usually call as business intelligence. What has already happened? What are the reporting on what has already happened? We do a lot of big data with machine learning, so tending towards the AI side of it. Let's start doing predictive analytics based on what has already happened. And then, of course, a lot of data governance. I'll talk a little bit more about that. I think that is one of the biggest topics that I have in front of me right now is combining AI, ML, and data governance. So if I walk through just a typical big data stack at Zalando, let's start from the bottom right. So business intelligence, I was saying it's the reporting. So things have already happened. We have already bought a shirt. That shirt is already in our warehouse, and it has been shown to people. How many people actually looked at it? How many people actually bought it? How many people returned it? Was it the right size when they got it? Was it the wrong size? Why did they return it? All of this thing can be seen by the data warehousing, by the KPIs. We use things like MicroStrategy, Tableau. We use a bunch of open source for that. And then, of course, we create some of these trusted data sets. So now that we have looked at this data, we know that this data is accurate. We mark it as basically a gold set, and we say, hey, here is data that the data scientists can use, the operations guys, the analysts can use, and they can trust that this data is accurate, right? Now, the second part of it is the data platform. The data platform is all based on the cloud. This is our data lake. It's using things like AWS. It's using GCP, Google. We use everything from BigQuery to S3 to Spark. We are a very heavy Spark shop. We're moving very heavily from traditional ways of doing ETL into Spark-based ETL, et cetera. And then this goes into the governance side of it, which is now that you have all of this data across all of these different clouds and in-house, you have it on GPUs, et cetera, how does the data scientist actually know what's there? And how do they know whether they can trust it? So you have to create a catalog. You will have to start putting information into it. And you can't do it all by hand. So you have to use machine learning and automation in order to fill those catalogs, to create those catalogs, and then have human oversight on top of it. And of course, machine learning. So we have machine learning. We usually do machine learning on AWS with GPUs. Without GPUs, we do deep learning. The kind of example that the last set of people showed, very interesting. We do very, very similar things too. But we also have teams that are very early in that process and teams that are very late in that process. And by the way, for every one of these, we're hiring. So if you're looking for a job, come talk to me. Let me walk you through a couple of use cases of how machine learning is actually used. And we'll focus in on machine learning for most of the rest of this presentation. So size recommendations. When you go to the website, what size shirt should you be offered? What size shoe should you be offered? The search experience, the kind of example that the last folks had. When you do a search, what should you be shown? What is the best view to be shown? What is the right thing to be shown? And then, of course, the stock. Remember, these things we don't actually sell rooms that already exist and don't change. We sell inventory that changes. If the Kardashians come up with something different, everybody wants to buy those. We have to react very quickly. We have to get those in there. If you do a web search, you'll find out that last summer, Germany had a really, really good summer. Europe had a really, really good summer, which was really bad for us because we were not ready for it. And so all of these things happen with machine learning. You really have to predict beforehand and say, hey, the weather's going to be like this. Let's stock the right things. Let's show the right things so that people actually buy what they need to buy. Personalized marketing, of course. We spend tons of money on personalized marketing, Google, Facebook primarily, but a lot of other places too. How do you make sure that you show just what people need to see and not more than that? And other examples like that. So I thought I would show you a real-life example. I moved from Silicon Valley, like I said. I was literally living out of a bag. And I was actually commuting from Silicon Valley to Berlin. And I was asked to speak at a conference. So I said, you know what? This is Germany. I should get a jacket. And so I went to the website, and literally I took screenshots when I was doing this. So a couple of interesting things that I noticed. This is me searching for a suit, and I noticed that, it's a 59.95 euro jacket. And that just was surprising to me because I didn't think that a good jacket I could get for 59.95. But what's actually happened behind the scenes is I had been buying some really inexpensive clothes because I was living out of a box, and I was literally, just get the basic cheap stuff and I'll throw it away when I go back next time. And so it actually learned that KK is probably going to be more interested in cheap jackets, so it offered me a nice cheap jacket, which actually worked out well. I still have it. So this is also behind it a near real-time recommendation engine. All of this is happening, in milliseconds behind the scenes. So the machine learning has been done. The models have been trained. They're being served in milliseconds behind the scenes. What's happening is, if I looked at one jacket, what are the other jackets that might be interesting, right? And then, of course, not just that. If I'm looking at a jacket, what about other things? Maybe I want a tie. Maybe I want a shirt. So as you can see, everything that's happening behind this is all driven by data. Multidimensional product placement, the search, recommendation, and of course the fit. So if I bought that jacket and I had to return it because it was too loose, then we have a very, very good return policy. So we take things back up to 100 days after we've sold it. But what that means is the person who has to return that has a very bad experience, because I bought this jacket, I have to go to a conference, and now I won't have a jacket to wear there because it didn't fit. So it's really important for us to actually tell you exactly which size will fit you based on what you've done in the past. So I wasn't sure how much people know about the machine learning journey. I thought I would walk a little bit deeper into what the machine learning journey really is like. So ML 101. Pardon me, those who've done this many, many times. The first step is the one at the very top, which is, how do you know what data you have today? And how do you know whether you can trust that data? Because, like I said, I have data in 3 clouds and 500 other systems. We have petabytes of data sitting around. How does the machine learning person actually get access to this data? That's the first step. How do you give it access to them? And the second is getting it from there. Getting it from there, cleaning it up, making it available so that you can actually do the machine learning with it. The third step is preparing it. Before you can actually do ML, you got to find out what are the negatives, what are the ones that need to be removed, what are the outliers that really don't make sense. But once all of that is done, you start training this. When you're training it, you want to train the model with a set, you want to test it against another set. And if all of that is working, then you deploy it to production. Now, in some cases, like the recommendations, your production might be, I need to deploy it, I need to get it out there in milliseconds. In other cases, I'm buying a jacket, I'm buying 5,000 jackets for next fall. Well, I can take days. So very different use cases, right? Millisecond serving versus could be days serving. And then, of course, does it work or does it not work? And then how do you do reinforcement learning, et cetera? How do you modify it back to something that makes sense and go back into the same cycle? Now, what this did, when I came in here, my mandate was basically democratizing machine learning at Zalando and data at Zalando. And we did company-wide OKRs. People who are familiar with the objectives and key results philosophy, we had the whole company line up behind us and say, all right, let's get all the right data into our data lake. Let's get one good cutting-edge set of products that we can use, tools that we can use. And when we did that, something very interesting happened. There was a huge number of use cases that started popping up. And they were often coming from the business guys. They were like, hey, I want to do this. Can I do this with ML? And of course, sometimes they didn't have teams. Sometimes they didn't have tools. Sometimes they had 1 or 2 people. So there were an exploding set of use cases, exploding set of people who wanted to do these things. But what they didn't talk about and what they didn't realize is that they actually had needs like this. It needed to be inexpensive. It needed to be safe. There is GDPR. We are in Europe. And it has to be cost efficient. They can't actually spend too much money just to test out these A/B models. So we had to achieve a balance. Now, if you look at that ML use case that I'd shown you, excuse me, the pipeline is really like this, which is start with a use case. You can use notebooks or other UIs to create the workflow itself, find the data, fetch that data, clean out that data, create a model, train that model, deploy that model, and then when you've served it, you want to see what it actually is doing, get the feedback, and do the whole thing again. Not too difficult if you're doing one set, right? You've got 5 or 6 machine learning guys. I have about 200 some machine learning guys right now around the company. Not all of them report to me. I only have a 100-person team, but there's a whole bunch of people in many different business units that are doing all of these things. And so it's OK when you're doing it once. It's OK when you're doing it twice. When you have dozens of teams which are actually creating machine learning use cases, exploring the data, fetching that data, training that data, serving that data, monitoring that data, and you want to remember those 3 things, the cost efficiency, the scalability, the safety, now all of a sudden the problem becomes really, really difficult. So what did we do? We went out and we looked at all the open source tools out there. We looked at best practices in other companies. We talked to a lot of the vendors that are out here. We had some very deep dives. I'm from Silicon Valley, so the nice thing was I could always go back to California and sit with people there and ask them, hey, how are you doing this? And we took advantage of that. We came up with a way to tackle this machine learning challenge, the scaling challenge. Really 3 parts to it that we ended up focusing on. One was, how do you do this really fast? So how do you compose these training jobs really, really fast? How do you tune them? And really, you need to provide. Remember, machine learning is just creating a model. It's just creating a way for you to understand certain things. You need to create an endpoint. It's almost an API that people can use once you've created this model. So how do you create all of these things, create that model, give it to people? And how do you do it safely? How do you make sure that you're always following GDPR? How do you make sure that the catalog is there? How do you know what the data is in there, et cetera, et cetera? And then how do you do it cost efficiently? The margins in a retail business, especially an online retail business, are very, very small. This is one of the reasons why Amazon wasn't profitable for the longest time. This is not an easy thing, and you don't want to waste a lot of money when you're doing ML. So what we ended up doing was we created a really sophisticated set of tools. We took a sophisticated set of tools. Spark is our main core ETL engine right now. We use everything from Oracle to Exasol to MicroStrategy to Tableau, et cetera, on the BI reporting side. We use S3, we use AWS, you name it on AWS, Presto, et cetera. Our data lake is based on that. And we use SageMaker. This is actually a screenshot from AWS SageMaker. One of the things that it helped us do was to be able to create a visual so that the machine learning person doesn't actually need to spend a lot of time doing this. And what we really ended up doing was creating these 3 stages. As you can see, this part of it is based on SageMaker. SageMaker is not the only tool we use, by the way. There are teams inside. I've talked to Google Kubeflow many times. I've talked to Databricks MLflow many times. There are startups that I talk to all the time to figure out what tools they suggest we use. But this is one example of how we do this with SageMaker today. So let the developer actually do the development on their laptop or wherever they need to do it. Commit it into version control, start that CI/CD pipeline, get it into production with SageMaker, and then get the feedback, be able to monitor it, watch, see what's actually happening, and then go back to the beginning of the process, right? A machine learning person's job is never done. Now, some of the things that we had to put together also were monitoring. So I'm just showing you one job, one training example. You can actually look at, when I trained this, what kind of CPU utilization did I have? When I served it, what kind of CPU utilization did I have? How did I utilize memory, et cetera? I have a few other slides. If somebody is curious, I can show them offline. On every stage of that machine learning journey, what did somebody do? How did they do it? How could it do it better? And of course, remember, once this is done, this is a cycle. This keeps happening. So let's say I created a model, and it worked great, like in the last example, the bathroom example. Maybe the first time I did it, it was actually working really well. Then I went back again, and then the second time it was showing me these bathroom pictures, which didn't work very well. And by the way, it's not acceptable for the business person to not look at this and tell you whether it's working or not. Everything that we do, the machine learning guys, the development guys, have to look at it from a business perspective and say, hey, is this working? Is this not working? And then once that's done, you want to be able to go back and say, oh, dang, that last model that I'd created 2 months ago was working better. How do I go back to it? How do I look at the code that was there? How do I do all of these things? And this is not coming out of the box from any vendor. You really have to do it by yourselves over a period of time. So Final slide. Where would I like to be in 2020? I want to be able to have a scalable, cost-efficient, yet flexible infrastructure for the data. That's bottom line. What I want to be able to do, and I can't do as well today, is sharing all of these models, sharing all of these data. Right? Every time somebody creates a Tableau dashboard or a MicroStrategy dashboard, I want to be able to share that dashboard with others, as long as it's allowed to be. Not just the models. And then features, create a feature lake, et cetera, right? How do you share all of this? And then do all of this safely. How do you do all of this with privacy concerns taken care of right off the bat? Because you don't want your machine learning guys or even your data analysts worrying about privacy themselves. It should be provided to them so that they don't have to worry about it. They can do their own job. And then the last one is you won't find one set of things that do all of these things. So you have to look at open source. You have to look at inner source, because there are people inside your companies, your organizations, that are actually doing it today. How can you learn from them? And then, of course, you have to look at the vendors. We work with startups, we work with the biggest companies out there, and we work with a lot of companies in between. With that, I will stop with one last thing. We are hiring. Come talk to me if you're interested. Thank you.
Thank you, KK, for the presentation. Now we have 5 minutes for your questions. Please ask them now.
I answered all the questions beforehand.
Really?
No, I'm kidding.
But I have a question, maybe.
Sure.
How do you involve the business unit, so sales, marketing, and so on? Is there maybe a budget for advanced analytics or something like that?
Absolutely. So what we found out very quickly was, if you're not solving a business problem, it doesn't matter how good your algorithms are, it doesn't matter how good your visualization is. If you're not solving a business problem, you're doing something wrong. You should not be there. You should leave. And therefore, what we did, number one, was we went out, we started with the business. Right? So we have product people who sit with our data science teams. We have product people who sit with the actual business, and it's their job. They are the customer's voice, literally, and they're talking to the customers. They're really embedded in there. One interesting thing that we learned was that there is no way of doing data right in a central fashion. So you cannot just have a chief data officer and say that the chief data officer is going to run data for the whole company. No, that doesn't work. Every business unit has to have people that understand data. They have to have people who are sitting and talking with the people who are monitoring the revenue. They have to have people who are also talking to the machine learning guys to say, hey, yes, I would like to do this, but is it even technically feasible? Is it possible? So our best practice so far has been to have a central organization, which is the one that I run. We provide the basics. We provide the help for people to get started and move forward. But then every business unit actually has their own data people who work very closely with us. They work for operations. They work for machine learning. And that combination of having a central organization and having depth inside each group works very well, we find.
OK, thank you. I think there is a question.
Hi, my name is Nadeem. In percentage, how much of this machine learning workflow is automated, fully automated nowadays? So I totally understand that you need all of that stuff because you have tons of machine learning workflows up and running. But what would you say? 10%, 20%, 80%, 100% automated to train the models, to create the features, all that stuff?
So if I talk about complete automation, I think it's 0%. Okay. There is no complete automation. But for every piece of that journey, there are pieces that are automated. And it actually does, it's a really good question because every team that is doing machine learning is different. So there are teams that have been doing machine learning from long before I was there in the company. And they are very sophisticated, and they have moved forward without using the tools that we gave them. And they have actually built that automation. And they can be, in some cases, very, very high automation. There are others who are just starting. And for them, we give them that automation from using tools that I was just talking about.
So how do you bring these people who already did machine learning before into the way of, like, do you have a code of conduct or a guidelines or whatever? Because they did machine learning before the ways they did it. And now you're coming up with the workflow where you say, OK, this is the workflow. We have to do it from now on. But then they come and say, hey, my models are delivered like this and all that stuff.
And that's a practitioner's question. Very good question again. So the question really is, there are teams that are going to be so advanced that if you force them to do certain things the way that the rest of the company is doing, it'll slow them down. And the company cannot afford to lose revenue because you're going to slow them down. So I think I took a page out of the book of Silicon Valley, right? Don't fix it if it ain't broke, which means, is it working for them right now? If it is, we don't force them. What we do is I force my team to be so advanced and so cutting edge right now that those people look at us and they come to us and say, you know what? It's going to be hard for us to do this, but we really want to see what you're doing. I'll give you an example without naming names. One of the largest companies in the world, their machine learning, next generation, cutting edge technologies, right now, today, we are considering whether we should be launch partners for them, right, in that central function. Now, 2 years back, they would not have considered Germany. Forget Germany, they would not have considered Europe, right? Forget a little company called Zalando. And so, having brought them to that point, when you start seeing this, when you see these biggest companies in the world wanting to be launch partners with Zalando on their next machine learning technology, that's when those teams which are already doing these things look at us and go, you know what, maybe it takes time for us to do this, but maybe it's the right thing. Let's work very closely. So you really have to show them. You can't force them. You're welcome.
Okay, thank you. I think one question could be left, if there maybe, is there maybe one?
Thank you very much. So this question is maybe a bit of from a customer perspective. So my question is, do you have an ML use case for telling people apart if they are using one account to shop? So like an example, I regularly shop for my husband, and I see that it's totally confused what to recommend me.
So
my question is, do you have a machine learning use case for this, or do you plan to implement them?
we do actually, and without talking about the details of it, you can actually tell whether there are multiple personas inside a household, inside an account, and what they are shopping for. And so sometimes it does get very confusing when my son browses the page, or when my wife browses the page from my laptop and is trying to get something from Zalando. They can see some very interesting results, and when I come back the next time, I see some very interesting results. So the machine learning team does actually recognize behind the scenes what is happening. I don't have any specific examples of what we are doing with that, but you're right, there are multiple personas, and you can detect that this is probably not the same person who was shopping there. I mean, my son lives in New York, in Manhattan, and when he shops on Amazon, and I shop on Amazon from Germany, Amazon actually sees where we are coming from, and it shows us different things. We both use the same account, but what Amazon does is when I shop here, they show me a totally different set of things just because they see that I'm coming in from the .day domain. And it shows him in Manhattan a totally different set of things because he's coming from a different place. So yes, you can recognize it, and yes, you can show different things based on that.
Okay. Thank you again, KK. Thank you.